Welcome back to Prescriptive Analytics. And in this particular lecture, we're going to talk about investment problems where we're trying to maximize our investments and looking at the risk here. So the last problem you looked at was more from a manufacturing operations, production and operations perspective. This is more from a financial perspective where we are looking at the investment issues and how we're going to model that problem. My name is Hari Rajagopalan, and I will be walking you through this particular problem. So let's look at the company. Brian Givens, financial analyst for retirement planning services, is looking at designing retirement income portfolios for retirees using corporate bonds. He's just completed a consultation with a client. The client has about $750,000 to invest when she retires, and they want to consider bond issues from 6 companies. And I'll show you the 6 companies in the next page. Now, financial analyst believes that all companies are safe investments. However, to protect his client's income, they have agreed no more than 25% of their money should be invested in any one investment. So 25% off the 750. At least half of the money should be invested in long-term bonds that mature 10 years or more. And then we have these 3 bonds. Dynastar, Eagle Vision, and OptiPro offer highest returns. They also agree that no more than 35% of the money should be invested in these bonds because they represent the highest risks. So let's look at these. Here are the companies. You have Acme Chemical, Dynastar, Eagle Vision, Micro Modeling, OptiPro, and Sabre Systems. Here are the returns of investments, 8.65% and so on. Here is years to maturity, and here is the rating, right? So we have some specific requirements, which are our constraints, and we need to go ahead and set those up. So let's look at some of them here. So 25%, half should be in long-term bonds that are 10 years and more. No more than 35% should be invested that represent the highest risks. So the highest risks, are the ones which rated lower than very good. So anything which is 3 and 4 have the highest risks. So here's the information. Client wishes to 750,000. Information was in the table. We talked about that. No more than 25% in any one company, at least 50% long term, and no more than 35% in these, Dynastar, Eagle Vision, and OptiPro. So let's do a thought exercise. Let's think through this problem. And again, the first thing you've got to look at when you look at this problem is, what do you need to decide? If you were modeling this problem, you need to decide. So you have 750,000 to invest, and you need to know how much to invest in each of these bonds, right? So essentially that's your decision you need to make. And then your objective is to maximize your total returns, okay? So it's a very, it's not that hard, this problem. And if you can look at this and say, here are the 6, you can use X1, X2, X3, X4, X5, X6, or you can use A, D, E, M, O, and S, depending on what you want to do. So the decision variables, I've used X1, X2, X3, X4, X5, X6. This is the amount of money to invest in each of these products. And so when we want to maximize our total annual investment return, you can either maximize the interest, or you can put 1.0865, 1.095, 1.1, which will also give you back your principal. Either way will give you the same answer, just the objective function will be different, okay? And it's subject to certain constraints. First is you have only $750,000, right? And therefore, if you have $750,000, the total amount you have has to be $750,000. So we need to make sure that the total amount you have, which is x1 plus x2 all the way till x6, this is equal to 750, right? So that's your first constraint. The second constraint is that no more than 25% in any one investment. So x1 has to be less than or equal to 25% of 750. x2 has to be less than or equal to 25% of 750, which is 187,500. Also, 50% long-term investment restriction, which means that x1, 2, 4, and 6 are long-term investments, and you should be more than 50% of your income, that is 375,000, have to be invested in that, right? And then Dynastar, Eagle Vision, and OptiPro should have less than 35%, and that's x2, x3, less than 35% of 750, which is 262,500. And of course, all of them are non-negative, so therefore they all have to be greater than or equal to 0. So let's go to Excel, but before going to Excel, I just want to show you that the way you set this up is exactly how you set up the previous problems. There is no change in how you set up this problem. So as you can see, you start off with x1, x2, x3, x4, x5, x6. This is the decision variable, objective coefficient. You put all the constraint coefficients here, some product here, some product here. You can then leave a column blank and then put the right-hand side values. Or you can just, if you're used to it, you don't have to do that. So let me go to Excel. I'm going to do it one more time. So I'll do this problem, and the next problem I'll actually walk you through Excel. But after that, I'm going to expect all of you to be comfortable in setting up problems in Excel and do it yourself. I'm not going to show you how it's done. Okay, so I'm going to show you this model. Now, when you download this Excel file, you'll see it set up here nicely. You'll also see this investments too. I'm not going to go over the second part. I will be going over it in class. When we meet up face to face, I'll talk more about this. I'm just going to show you this model. So let's start. As you all know, you're going to start off with x1, x2, all the way up to x5 and x6. So let's start with that. Let's get your, I like this font, so I'm going to set it up in this font. I like things to be centered. It makes it easier to see. And so let's put the 0.0865, right? And these are, so leave the first row blank, right? We are going to go ahead and leave it blank. The second row, I'm going to put the objective coefficients. And as I said before, some of you might want to do 1 point, might add 1 instead of the 0 to everything, right? And that's okay, because then the 750, you won't be just looking at the interest, you will be looking at the principal plus interest. So that's perfectly okay. So here is your objective coefficient. Let's go ahead and write it down. This is your decision variable. And the first one is total investment is 750. So we're just going to put 1111. This here would be $750,000, right? Equal to the second one. So I'm going to show you one way of doing this, and there's an easier way of doing this. So let's kind of one way of doing this, x1 less than 187,500, is you're going to put x1 and you're going to say less than or equal to 187,500. Then you're going to do x2 and you're going to copy that. And then you're going to do x3, x4, x5, and x6. And you are pretty much going to copy this down, right? Now, if you have 15 investments, this is going to be a long one. So let me show you a easier way. Go ahead and delete this. And we will do this at the end. Okay, this 187,500. So let's go to the next one. The next solution was 50% restriction, right? So because this is a greater than, and it's fine right now, we'll just use that. So we have x1, x2, skip x3, x4, skip x5, x6, and this will be greater than or equal to 375, okay, 375,000. And then you have the 35% restriction. This is x1, skip x1, x2, x3, skip x4, and x5 is less than or equal to 35% of 750,000. You could even do this way, but once you do it, make sure that you copy and paste values. I think the new analytics solver is comfortable with these being formulas, but the old one wasn't. And if you use Excel, it definitely doesn't like these values to be formulas. So these right-hand side values should be actual values. So they're all dollars, so we're going to go ahead and put that. We're going to use sum product here. Oops. All right, sum product, F4, comma, second row, right? And then you can just copy this down. These are all dollar signs, so we can just put currency here. And now let's look at this 187,500. I'm going to put 187,500 all the way here. This is the maximum. So I'm just going to say max investment, right? Max investment is 187,500. And I'm just going to put it here. And I'm going to show you how this needs to be set up. All right. So we have taken care of it. Objective coefficient right here. And we have set it up. So now let's go to Analytics Solver. And wait for it to open up. And here we go. So let's go to Optimization Objective. We are trying to maximize M3. Okay, so this is what we're trying to maximize. Our decision variables are all here, right? And then our constraints are this here. Now you can't select a whole bunch. So remember, when you do constraints, you're not selecting anything here. It's basically these values that you're selecting right here. Okay, so you're going to do this here is equal to 750. Add this one is greater than or equal to 375. Add this here is less than 265, right? Now, if you had a whole bunch of x1 less than 187, you could have done just added all the less one. But now I'm going to essentially select. I'm going to create constraints which are boundaries. So I'm going to select the decision variables and say add constraints, and then say less than these values, right? And notice that they won't come here, but they'll end up right here on the boundaries. Okay, and of course these are non-negative is true. If you want, you can go select the LP quadratic, but if you automatically select engine, it should be okay. And you can run it. And when you run it, here you go. So your return on investment is about 68,887.5. but you're actually going to get your 750 back and this. So this is your total amount you're going to get back. This is just the interest. So for those of you who are doing 1.086, you will actually get this value. This is the value you'll see. For those of you who are just using the interest, you're going to get this value. So you'll notice here is the answer. It's asking you to invest. Let's go ahead and put currency here. It's asking you to invest 112,501, 75,002, the maximum 187,003, this in 4, nothing in 5, and then again in 6. So this is what it's asking you to invest. You will notice here that I have modeled this differently. Look at this, 1, 1, 1, 1, 1, 1, right? So it becomes rather big, and you'll see that these are all now normal constraints because I've set it up this way, right? In this case, I've set it up differently, and therefore it comes here as the boundary. So I'll go ahead and save this so that you can see both these setups. As I said, this one, ignore this. I will actually go over this in our face-to-face class. And so you do not have to look at this right now. We'll do it in class. And with that, we finish our investments.